So today I'm going to be teaching the skill I can graph a rational function to show key features, and the key concept is how to find key features by looking on a graph. So the first graph I'm going to show you how to do is f of x equals x minus 2 times x plus 1 over x minus 2 times x plus 5 times x minus 3. So first you're going to find your x-intercept, which is the point or points at which the function touches or crosses the x-axis. So you are just going to look where the graph crosses over the x-axis, and in this case that is going to be right here at -1, 0. Then you're going to find your y-intercept, which is the point at which the function touches the y-axis. And so you're just going to look where it touches or crosses the y-axis. And in this case it's right here at 0, -0.067. So next we are going to find a hole. And the hole is where the function has a break, or the x value where the graph's y value is undefined. So, and these only occur when the numerator and the denominator have a common factor. And in this case they do. It is x minus 2, as you can see, it is right there. And so to find where you're going to need to look on the graph, you're just going to set the factor equal to 0 and then solve. So in this case you would look where x equals 2, and that is right there. So then you are going to find your domain, which is all of the x values of a function. So your domain is, it starts at -infinity, and then it goes to 5, and it goes from 5 to 3, and then, it goes from -5 to 3, and then it goes from 3 to positive infinity. Then you're going to find your range, which is all the y values in a function, and this is all real numbers because it goes from positive infinity through to -infinity. Then you're going to find your asymptotes. And an asymptote is the line that a function approaches as x approaches infinity. So first you'll find your vertical asymptotes. And to do that, you'll find the vertical line that the function approaches but never reaches, and that is x equals -5. And you can see right here, it is approaching -5 but never reaches it. It's approaching -5 but never reaches it. And then for your horizontal asymptote, it's going to be y equals 0. And y does equal 0 right here, but this middle part is not in play when looking at the horizontal asymptotes. And you can see here, it's approaching, it is approaching infinity, and it's approaching 0, but doesn't actually reach it, approaching 0, not actually reaching it. And then your end behavior, which is how the function behaves as it approaches infinity. So as x approaches -infinity, y approaches 0, and as x approaches positive infinity, y approaches 0. So I'm going to do one more for you, and that is f of x equals x plus 4 over x plus 3. And so first, you're going to find your x-intercept. And so again, you just look where the function crosses over the x-axis. And in this case, it is right there at -4, 0. Then you're going to find your y-intercept. So to find that, you just look where it crosses over the y-axis. So that's going to be 0, 1.3 repeating. And there are no holes in this function because the numerator and denominator do not share any factors. Then you'll find your domain. So it starts at negative infinity and then goes to 3. And then it goes from 3 and goes to positive infinity. Then you're going to find your range. And your range starts at negative infinity and then goes to 1. And then it goes from 1 and goes up to positive infinity. Then you're going to find your vertical asymptotes. And there is one, and this one is x equals negative 3, because as you can see, the function is approaching negative 3 but never reaches it, and it's approaching negative 3 but never reaches it. And then you're going to find your horizontal asymptotes, and that is y equals 1. And as you can see, it's approaching negative 3 but never reaches it, and approaching negative 3 but never reaching it. And finally, you're going to find your end behavior. And so as x is approaching negative infinity, y is approaching 1. And as x is approaching infinity, y is also approaching 1.